All right, given the coordinates of SHA below, on number 10, by the way, is what we're on, last one, wants to know what type of triangle it is, so I'm going to use the Pythagorean theorem and figure it out. So I'm going to put the x's in, -2, 6, and the y's in, -1, 1. -2 minus 6 is -8, which when squared is 64. Plus -1 minus 1 is -2, which when squared is 4. I think just making sure I was remembering that number somewhere else. Yep. It'll be all right. It's a different question. So that's the square root of 68, leaving it in square root form. The next one is calculating the distance formula between A and H. So 3, 6, 4, 1. 3 minus 6 is -3. Quantity squared is 9. And 4 minus 1 is 3. Quantity squared is also 9. So this is the square root of 18. And lastly, I've got the distance formula again. This time I'm looking for the distance between S and H, and that would be -2, 3 and -1, 4. -2 minus 3 is -5. Quantity squared is 25, plus -1 minus 4 is 5. Quantity squared is also 25. So that's the square root of 50. So looking at the comparative size here, I know that the square root of 18 is the smallest, followed by the square root of 50, followed by the square root of 68. Okay, so I'm going to run a Pythagorean just test on it to see if they're equal. The square root of 18 squared is 18, the square root of 50 squared is 50, and that's 68. So 18 plus 50 is 68, and 68, when the two are equal, okay, you know that this is a right triangle. So let's see what we know. If it's right, it's not acute or obtuse, and yes, you have figured out something about this triangle. Okay, then if you look at the sides, square root of 68, 18, 50, all three sides are different, so it's scaling. So we're going to get rid of isosceles, equilateral, and equiangular, which means this is A and E, a scaling right triangle.